Hello students, now we will discuss special cases of projectile motion. Okay, this video is brought to you by Site India E-Learning for online classes from anywhere and offline classes only in Lucknow. Please click the link, this one, to see contact informations. Okay, special cases of projectile motion. When we derived the equation for path of projectile motion, body or say projectile is thrown from the ground at an angle, but here we will see that body or say projectile is projected from some height. First case horizontally, second case at an angle theta up with horizontal, and third case at an angle theta down with horizontal. We will discuss three cases of projectile motion. For the numericals to solve such problems, we cannot use formula which are derived when body is thrown from ground at an angle theta with horizontal. Okay. See, case 1, body is projected with velocity u0, horizontally projected with velocity u0 from height h, from the top of a tower of height h. The path or say figure will be as seen in front of you. Body is thrown horizontally, then its path will be this. This is also projectile, this is also parabolic path. A part of parabola is also parabolic. The height is h. Now one thing is that time taken by the body to come from A to C via this path will be same as body is dropped from A and covers h height or say AB distance, or the time will also be same to cover x distance, that is BC, with horizontal velocity u0. The reason is that for vertical motion, acceleration due to gravity is same, either body is dropped from A and reaches B or moves along this path. In both cases, the factor which is taking the body downwards is acceleration due to gravity, and which is same. That's why time taken will be same. And in horizontal motion, there will be no change in velocity. We can keep in mind the time taken to reach C when thrown from A is same as body is dropped from A and reaches B. So we will consider AB motion. For A to B motion, what will be U? 0. Why? Because whole velocity at A is given horizontal, there is no vertical velocity at that instant when it is thrown from A. That's why vertical velocity, say initial velocity, is 0. That's why U0, height h is capital H, and we have to find time. Obviously acceleration will be taken as g using second equation of motion h equal to ut plus half gt square. What is h? Capital H. u0 into t plus half gt square, it will come out h equal to half gt square. By using this formula, either you can calculate h or t. H or t. It depends what is given to you. So this way, if you are given time, you can find height from which body is thrown horizontally. If you are given h, height, and initial velocity u0, horizontal velocity, then you can find time to reach the ground. But if you want to find horizontal distance moved by the body x, then it will be horizontal distance x is covered with velocity u naught, which does not change because there is no force acting horizontally. That's why it will be constant. And for constant speed, we take x distance equal to speed into time. That is u naught into t, which either be given to you or you have calculated this way. Thus, you can find horizontal distance as well as height or time as required. Okay, this is the case 1. Now case 2, body is thrown at an angle theta with horizontal, up with horizontal. This is the case in which body is thrown horizontally, but now I am taking another case in which body is thrown at an angle theta up with horizontal. Up with horizontal. See how time is to be found and the horizontal distance. We will find in each case time and horizontal distance. We are taking here that we are given height. This is height from which body is thrown. I am taking it as capital H. Point A, this is B, this is ground. Okay, body is thrown at an angle theta up with horizontal, this way. This is u naught and this angle is theta. What will be the path of body? This will cover a curved path, and which will be parabolic in shape. This will be the path covered by the body, and this is horizontal distance x. See this point C. Okay. Now how to find time taken by the body to reach ground? Say point C. Okay. We'll do components. One component will be horizontal component. This is u naught cos theta, and another component will be vertical, and this will be u naught sin theta. U naught sin theta is taking body upwards, but if we take downward velocity or say downward motion, then we'll have minus u naught sin theta. If body is going with velocity u naught sin theta upward, then body is coming with velocity u naught sin theta downwards. Take opposite sign. Okay. Now time will be same. Either body is dropped from A with this velocity and reaches B, time will be same, or body is thrown this way and acquires this path and reaches C. Okay. Now for vertical motion. For vertical motion, we don't have any way to find time via this path. We'll consider obviously vertical motion, which is accelerated motion. For vertical motion, what is u? Minus u naught sin theta. Body is coming from A with velocity minus u naught sin theta downwards. What is h? This is capital H, and t is to be found. Again using second equation. Second equation of motion. H equal to ut plus downward motion we are taking, that's why plus half gt square. What is h? Capital H, u minus u naught sin theta into t. T is not part of theta, not with theta. Sin theta is separate from t, plus half gt square. You can solve this equation to find h if you are given t, or if you are given h you can find t. It may be quadratic equation, you have to solve it. then h equal to question mark or t equal to question mark. Obviously, if h is given, find t, and if t is given, you can find h. You may be asked h. Now, horizontal distance, if asked horizontal distance, in the same time, the time taken by the body from A and reaching C, or thrown with velocity minus u sine theta and reaches B, or horizontal distance x, in all the cases time will be same. X distance, horizontal distance, is covered with velocity u cos theta. U cos theta is taking body horizontally. That's why, and which is constant, horizontal velocity does not change because there is no force acting horizontally. That's why x equal to u naught cos theta into t. Okay. Sometimes you may be given x and u cos theta as well. You can find t using this formula. Then you can use value of t to find height. Whatever be the case, this was type or case number 2. Now I will discuss case number 3. In this case, body is projected at an angle theta up with horizontal. Now I will take body is projected from top of a tower at an angle theta down with horizontal. Okay, down with horizontal, pattern or method will be same. Just form the figure, do components and apply second equation of motion. We have to find out what should be u, or say initial velocity. See, this is a tower or say something of h height. It may be a hill. This point is A, this is ground, this point is B. Body is thrown at an angle theta down with horizontal this way. Path will be this way. Okay, this is horizontal, and with horizontal the angle of body is theta. This velocity is u naught, and this distance, say horizontal distance, is x. You can see this point as C. Again, we will see that for AB distance, what is the component of velocity u naught which is taking body downwards. Then we will see two components. One is horizontal component. This will be obviously u naught cos theta, and vertical component which is taking body downwards, u naught sin theta. Okay, body is thrown with velocity u naught, or this at this angle, or body is thrown from a vertically downwards with velocity u naught sin theta. Same thing. Time taken by the body to move via this path and reach C will be same as body is thrown with velocity u naught and reaches B. Okay, we'll take vertical motion. For vertical motion, what is u? U naught sin theta. What is height h? Capital H again, and you have to find t. Using second equation of motion, h equal to ut plus half gt square. What is h? Capital H. This height is covered with initial velocity u naught sin theta. Ut, what is u? U naught sine theta into t plus half gt square. Solving this equation you can find h or t. Obviously one of them, either h will be given or t will be given. Now horizontal distance, x. Obviously horizontal distance x is covered with velocity u naught cos theta, which is constant. And for constant velocity we use this formula, x equal to speed into time, u naught cos theta into time, which we have calculated using this equation. These are major types of numericals on projectile motion. Whatever be the case, from this figure put the values and you can calculate or solve these three types of problems or say numericals on projectile motion. If body is thrown with an angle with horizontal from the ground, then the direct formula for vertical height or say time period or say range you can use directly. But if thrown from some height, that is these three cases, you have to proceed this way. Just fill in the blank and you can solve the problems. Okay, have a nice day. Thank you.